Hi guys, I've got a new video to show you and I'm calling this Quantum Harmonics using Quad Step 288. In the last couple of years, I've shown a lot of progress with a system called Quad Step. So let's take a look at some of the things that you can make with Quad Step. First, I'll show you the 200 seed pattern of a strawberry. And now I'm going to show you a pineapple and a pine cone. Now you can see when it comes to 3-dimension, this Quad Step does a lot of stuff. And let's take another look, the hand of a human being. Let's take a look at that. You see, it starts with the red, then we get 4 colors, and then it starts again with the red. But what's amazing about Quad Step, it produces such wonderful helical order, 3D helical order. Now this illustration in front is from an earlier video, but it shows how sine waves can be formed with Quad Step. Now I've been doing a bit more research on this Quad Step system. So I'm going to start off showing you something very simple to start. Okay, I'm showing in front 3 rings. I want to make a circular array of 20 copies of this center ring, but I don't have a center. Okay, I've come up with a solution. I rotate the top ring minus 9 degrees and the bottom ring plus 9 degrees, about the center ring. So the next step 3 is to make a circle from the 3 center points of the 3 smaller rings. Okay, the next step 4 is now we can move the circle and the ring to the center axis 0, 0, 0. So now we have a good center to start giving us an array. Now we'll give the small ring 20 copies array around 360 degrees. And look what we have. Now I usually do my stuff in 3-dimension, but I'm doing 2-dimension for this because it's easier to see the circles are not overlapping. Okay, now that we've got the outlines, now we can give it some Quad Step colors. Note that the size of the balls can be any size. I'm using 34, but these will be the size of the icosa. Okay, now that this 20 ring has worked out so good, I'm going to do the same for 16, 24 and 32 and see how things go. So I put a little bit of research into this and this is what I've come up with. Now you can see in front I'm starting with the red single ball in the center, and because we're working with Quad Step, it goes up in sections of 4, groups of 4. So it goes red, yellow, purple, cyan, red, yellow, purple, cyan. It keeps repeating. Okay, I've done a bit more research onto this, and as you can see in front, we're looking at the dual system. Okay, if we start with the single ring, red ring in the center, our next ring without overlapping would be 8, 16, 24 and 32. So let's show them on their own. So now I'd like to show you a little anim that I put together. You can see that this starts from the center and then it goes up in steps of 8. And I'm taking it all the way up to the 72 ring. Note that the colors and sequence are in a wonderful symmetrical order. This is very similar to the Dual Phi Phyllotaxis system that I showed, but I guess it got the silent treatment from academia. Okay, now we can look at the second half of this duo system. Now this secondary system starts with a ring of 4 to start. Then it goes to a 12, and then it goes to a 20, and then a 28, and then a 36, and then a 44, and then a 52, and then a 60, and then a 68, and I finish off with a 76. Okay, now we need to look at the fold system. I've decided to show the two systems together to make it easier to follow. Now, as you can see in front, I'm showing 10 rings in the first system and 10 rings in the second system. Now I'm going to show you the fold system. Now look at the left hand side A, it shows an 8-fold, and the B side shows a 4-fold. Also note that every ring is the same, but I guess it's a quad step, that's why. Okay, now we'll move on to the 3-fold and see what we've got. Now look at this, every 4 quad step ring is a 3-fold, and between the two sides it's going up in steps of 12. Okay, now we'll go to the 5-fold and take a look at that. Now something interesting to look at. It's going up from 20, 40 and 60 when you use the both systems. Now I really thought it went from 10, 20, 40 and kept doubling up, but I was wrong. And if you look, there is no 10, there's a 12. Okay, now I'm going to move on to an important feature that I found in this research. I found that there is a natural slope angle between the vertices of a string of Platonic solids. Okay, first take a look at the Yucatan slope, the 19.473 degree slope. If you tally up the long diagonals of the cube, we have a 3-to-1 ratio. Now if we do the same for the icosa, we get a 2-to-1 ratio. Okay, I've put an animation together, and this animation shows 220 ball rings of quad step, and I'm giving the first ring a 26.565 degree slope and the second ring a 19.473 degree slope. Let's see what we've got. And you can see in front that I show lines that give you the sphere diameter offset of 0.5, and in the 19 degree pico slope I show 1/3 the offset of the diameter of the sphere. I realize all this helical order contradicts the chaos theory equations, but when the scholars reject for publishing these discoveries, I don't think it's very fair. But I guess if the mathematicians teach us that the sine waves are flat, we have to do what they say. Anyways, for the very few people all around the world that shows a little bit of interest in three-dimensional order instead of chaos, this is Paul saying thank you very much for watching my video.